Hi everybody, welcome to the Server Virtualization Jumpstart. We got 2 full days of content planned for you covering every virtualization product related to server that we have. We are really going to try to go throughout the stack, with our first day focused on Core Hyper-V, our second day really focusing on how we can expand that management using System Center, specifically Virtual Machine Manager. Let's take a look at a little more detail over what we're going to be covering for the next 2 days. Over on day 1, we're going to really start by looking at the core infrastructure, some planning considerations, best practices for designing our virtualized environment. We're then going to look at how we go and install Hyper-V, get it enabled, get it running on your Windows Server 2012 R2 infrastructure. We're then going to really focus on how we can go and deploy and optimize these virtual machines, create our VMs, our virtual hard disks, and then do some basic management functionality with them. We're going to look at designing our networks, and then really go and try to take on some more advanced functionality, looking at Hyper-V Replica to allow us to do disaster recovery, and finally ending the day looking at failover clustering with Hyper-V. On our second day, we're going to be really focused on System Center Virtual Machine Manager. We're going to kick it off by doing kind of an introduction to the architecture and a review of the different System Center components. We're going to then look at managing our storage, network, and cluster infrastructure with VMM, creating a virtual machine library and managing those objects, deploying virtual machines using VMM, managing clouds, managing services, and then we're going to look at some of the additional System Center components with self-service using App Controller, and then backing up the data center with DPM, Data Protection Manager, and finally, monitoring the infrastructure with Operations Manager. Well, let's introduce ourselves. Corey, why don't you go first?
All right, so good morning. Welcome to rainy Redmond. My name's Corey. I am a subject matter expert, I guess would be the term of the day.
Term of the day.
For Hyper-V and System Center, and particularly around Microsoft's virtualization stack. My day job is basically I run virtualization data centers, design them, build them, manage them, troubleshoot them, support them, and kind of everything in between. So this is my day job, dealing with Hyper-V, System Center, the Microsoft virtualization stack, at a fairly deep level. Been doing this now for going on 15 years, going way back to the days when Microsoft first acquired Connectix back in the early 2000s. I don't know what the right way to say that is. 1900s is okay. The 2000s.
Early 2000s is yeah.
And even back before that was some of the earlier like mainframe type virtualization stuff that was out there. And ironically, I started my IT career as a DBA.
Nice. Now you have data centers today that you run. So one of the reasons why we wanted to bring Corey out here, show his real world experience running these large data centers. Tell us a little more about your data centers you've got.
So we are a hosting provider that focuses primarily on, I guess, a sort of a non-traditional scenario, which is lab and demo hosting. Mm-hmm. So, for example, things like the TechNet MSDN Virtual Labs, that platform. If any of you guys have been doing IT Camp, that platform. Literally hundreds, upwards of thousands of users on a daily basis that are running VMs. And we have a bit of a proprietary engine that does the deployment, but it's all based on Hyper-V System Center components and then some code that we produced around that. But we deploy literally tens of thousands of VMs on a daily basis.
On a daily basis.
It's and some of the infrastructure is pretty high end, with nothing less than 10 or 20 gigabit Ethernet, nothing less than 16 gigabit fiber channel, and it's all built around some of the newer technologies that are in 2012 and R2, like scale-out file servers, like storage tiering, like storage spaces, and some of those those key things that are there that have really let this scenario kind of blossom and bloom. It's not your traditional IT pro type, set up an accounting server and keep it running and back it up. But a lot of the same fundamental principles still apply. We just happen to deploy and destroy at a much more rapid cadence than most. So.
Very nice. Well, that's why we wanted to bring Corey in as one of our presenters to really take advantage of his real-world data center experience. I'm Simon Perryman. I am a technical evangelist with Microsoft. I've been at Microsoft about 6.5 years now. I spent my first 4 years actually as an engineer working on our high availability and virtualization products. So I got an opportunity to really understand the technology at a different level, actually build it, so really understand it down at the code level. That's enabled me to get a few patents, and for the past 2.5 years, I've been a technical evangelist, covering our private cloud technologies, our virtualization technologies, and really making sure that I'm familiar with not just Microsoft's virtualization stack, but also VMware's virtualization stack. And so you're going to hear throughout the day, we are going to make some comparisons at the technical level between these two technologies to really try to help you guys, if you're VMware admins, more rapidly understand how Microsoft does virtualization and the difference between the two platforms. With that, I am a VMware certified professional as well, and coming out very shortly is the upcoming What's New in System Center 2012 R2 book, released by Microsoft Press and O'Reilly, that I contributed to as an author. So stay tuned for that if you want kind of some more in-depth understanding of what's going on in 2012 R2. Well, with that, let's quickly review what we're going to be covering throughout the day. Now, our target audience is IT professionals, and this exam training, it's not necessarily only to prep you for the exam. We're really trying to give you a broad foundation of understanding Microsoft virtualization. So we may start the day off kind of covering the basics, going, what is virtualization? What are some best practices? To make sure that everybody has a consistent foundation for why we're doing what we're doing. After that, we're going to be going a little more technical, really diving into every feature, every component offered by Hyper-V in the first day, and then System Center Virtual Machine Manager in the second day. So if you're brand new to virtualization, we will get you covered. If you've done VMware virtualization, we have you covered. If you're experienced with virtualization, we also have you covered because there will be a lot of focus on what's new in our latest releases with Windows Server 2012 R2 and with System Center 2012 R2. Now, we do want to encourage everybody to take the exam afterwards, and there's probably a lot of questions about exam vouchers. Stay tuned. We will be telling you about how do you get the exam vouchers. Very shortly, we'll be sending out an email that will have all the information for how you can go claim this exam voucher. With that, I think we will get it started, and we're going to kick it off by first talking about some best practices about how we plan our environment, how we evaluate it, how we really make it ready to become a virtualization platform.
It is, and a lot of people, from a very practical standpoint, put too little weight on the planning phase of this. That, if you think back traditionally, if you, go back a number of years, you're going to buy a server. If you make a mistake, you made a mistake, but it's not horribly expensive because you've bought a server. Maybe it was a couple of $1,000s.
You could go use it for something else.
Yeah,
right?
When you're investing in a virtualization infrastructure, you have to look at every single component end to end and make sure that what you're buying is going to work well together and the entire solution is going to work well together. Because at the end of the day, every single component is that much more important. And as a result, the time and energy and at the end of the day, money that you invest in all those components is going to be a lot more. And so I find that, most virtualization administrators, if they've not kind of been in that their whole career, they come at it from the angle of, it's just another server. It's not just another server. It's not just another, fiber channel adapter. It's not just another network card. The impact of downtime is so much more significant that you've got to put that extra effort into planning, into making those purchase decisions, into having good relationships with your vendors, and having partners across the entire ecosystem so that when you put something in place, it's going to be there and be there for the long haul. So we're going to kind of go in and start taking a look at what are the things we think about when we look at evaluating an environment to move towards server virtualization. A lot of the thinking around this has changed in the last 10 years. We began talking about server virtualization back, 7, 8, 9 years ago with the first products around the era of Microsoft Virtual Server, Microsoft Virtual PC. And, back then, the things we think about, conceptually are similar to what they are today, but they've gotten a lot more involved as the technology has gotten better, and there's more that you need to think about and consider. Primarily as the hardware's gotten faster. Once upon a time, you never thought about CPU related to network cards. It just kind of wasn't an issue. Nowadays, with the advent of 10 gig network cards, you've got to think about impact of CPU on a network card and the type of network card you use and the features and the hardware level that it supports. So virtualization administrators tend to be hardware gurus. And they know to a very minute level of detail what different pieces of hardware are, how they work, and what they do. This particular module kind of start off talking about virtualization in general. What are the components of the System Center suite? And I think it's pretty important that we kind of get across this point that we're not here to talk about Hyper-V and then talk about System Center. The two go hand in hand if you're a large organization, or if you want to automate things or look at things at a higher level. Hyper-V is one piece. Hyper-V is the hypervisor. It's what sort of enables a lot of these scenarios to happen. But at the end of the day, if you're a large company or even a smaller, a mid-range company, if you've got a bunch of Hyper-V servers and you're not using System Center, you're doing it wrong, because you're creating a lot of effort that you don't necessarily need to create. And in fact, there's a lot of features within Hyper-V that only really light up when you put System Center on top of it to give you that 10,000 foot and down management view of everything. So we'll kind of look at what all those components are and the role that they play, because I think a lot of people in the world of virtualization, they know Hyper-V, they know VMM. Where does Orchestrator fit in? Where does Service Manager fit in? Where does Ops Manager fit in? And then the big question is, where does Configuration Manager fit in? And that one does not, doesn't fit into the virtualization stack quite as well, but it's often sort of forgotten about. We want to make sure we kind of, let you know where that fits in as well. And look at some of the evaluation tools, and then what's the role that Azure plays in all of this, right? Because we know private cloud and public cloud and hybrid cloud, and how does all that fit together? So that's what we're hoping to peel back within this module.
Yeah, that's a great point, talking about how we are really treating virtualization as different. And you're going to see throughout the course of the day that both in the software and in the hardware components that we look at, we will have special considerations just for virtualization. For example, now whenever we deploy a cluster, if it's a Hyper-V cluster, we actually change some of the internal properties. So things get triggered faster, things behave differently than traditional clusters. So that's going to be a key point throughout the day. And the second thing you mentioned was, this comparison of when do I use Hyper-V, when do I use System Center, Virtual Machine Manager. Well, really, you want to think about using Virtual Machine Manager when you start to manage at scale. You have lots of clusters, lots of servers, lots of hosts, and you need consistency. Because consistency is one of the key tenets that we have with private cloud, ensuring every service configured the same way, it doesn't change, it's standardized. That way, when we're running our virtual machines across different hosts, we get guaranteed the same behavior. One of the key things of virtualization is abstracting that hardware from the software, but we still want to make sure we have consistency, so VMs always behave the same way.
One of the big things I hear when I talk to network admins about this stuff, they say, VMM versus Hyper-V. They go, well, I like Hyper-V because I really get in and configure things, and I'm very close to it. I can manually do everything. And I kind of look at them and I go, well, you like DHCP, right? That kind of makes it all automated and gives you a nice global view, and you don't got to worry about it. Why would you not take that same principle and apply it apply it to the virtualization layer? And you see the light bulbs starting to go, yeah, maybe you're right. Maybe we'll start thinking about, well, I'm not going to care about the server per se and just define it as, as a policy or as a rule within VMM, and let it kind of take care of it. And there's features within VMM that make this simple and easy to do. So we'll see a lot of that more tomorrow than today. Today is more on the core technology piece of it, how Hyper-V works and all those underlying technologies. So again, just challenges of traditional computing environments. Why people move towards virtualization. Obviously, space, power, cooling, resilience essentially is the idea that this kind of, space, power, cooling is pretty obvious. If you have one server versus 10, you're using less of all of that. And as folks are moving more and more towards hosted data center environments where, I don't want to put the servers in my little, my doctor's office or my lawyer's office or my accountant's office. I want to put them in a colo data center. A lot of times you pay based on power, space, and cooling. And so the less you have of that, the cheaper it is to operate. I know we do, so why wouldn't everybody? But then there's another component, which is the resilience. One of the neat things that Hyper-V lets you do, and should say not Hyper-V, virtualization in general, is take any component and make it fundamentally highly available. If you have a legacy application that's not clusterable, how do you go ahead and make that how do you go ahead and protect that from underlying hardware failing? The answer is you put it in a VM, you put the VM on a cluster. If the hardware goes down, the VM will fail over to the other hardware and come back up again. And so you get that benefit of all of these pieces. Flexibility, you don't need to buy RAM, you can add RAM. Makes it a lot simpler, a lot easier to do, and then using only the resources that you need. Because the reality is most servers in small business, medium business, enterprise business scenarios are overspec'd. Because you buy more than you need and it sits kind of idle for a lot of the time. Well, with virtualization, you can scale it so that it goes up and down at different points in time, and you making better use of your resources. So server virtualization, we're not going to spend too much time on these fundamental definitions here. I think everyone pretty much knows what we're talking about here. The idea of running an operating system in a virtual machine to put a workload that would traditionally run on bare metal into a VM and just kind of go from there. But there is sort of a new concept.
Network virtualization.
And this is a really big, scary, confusing one for a lot of people. You're going to see this today with Hyper-V at a conceptual level, and you'll see it tomorrow within Virtual Machine Manager at a practical level. But to kind of sort of explain what this is in a nutshell, server virtualization is very straightforward. But what if you get into a scenario where you're a hoster, okay? And you want to run multiple tenants or multiple customers on the same fundamental infrastructure, and you want to let their VMs talk back and forth. The way that hosters have traditionally done this is through VLAN technology with switches. But frankly, that's a nightmare because there's limited numbers of VLANs. They've all got to be configured.
It's tougher to manage at the end of the day, right?
It's a lot tougher to manage. You know, some of the switching vendors, provide tools that can allow you to apply policy across switches, but what if you've got more than one vendor? Are they compatible? It's a very, very complex thing to manage. What network virtualization does is allows you to take one single switch and have multiple VMs that are connected to it, physical switch, that all have the same IP address. And what Hyper-V knows how to do is use something called generic routing encapsulation, or GR, which is the same technology that a lot of VPN protocols use, to encapsulate the packets as they go back and forth. So you could have two machines with the same IP on the same network, but they don't conflict with each other because they're in defined virtual networks. Now, all the components have to understand this, but once it's in place, you get away from this whole notion of managing VLANs. So it's a very abstract sort of topic. It's one of the more difficult things to understand, quite frankly. So you'll see it today at a conceptual level, tomorrow at a practical level. So just don't worry too much about it for now. But it's there, and it's, you may have heard of the term software-defined networking. That's network virtualization is an implementation of that.
Okay, now one of the things that we do at Microsoft is we have kind of our own way of using network virtualization. Now, we have a lot of developers, right? And we don't really want to limit our developers what they can do. Sometimes they need to have their own Active Directory domain controller, sometimes their own DHCP server, but we don't want those on the network interfering with other things. So at Microsoft, each developer, we basically give them their own virtual network. They have their own range of IP addresses. They can spin up to 256 VMs, their own domain controllers, own infrastructure servers, own networking components, and not interfere with anything else. So if you have kind of these developer environments that need to be isolated, yet still need access to resources, this is a great way to really try to take advantage of that.
Absolutely. So let's kind of take a look at some key technologies in the stack and then also how they compare to some of the technologies from VMware.
So first of all, let's talk about the hypervisor. So we both have hypervisors. Hypervisor kind of being the core component of a virtualization platform that basically does the layer of translation between the physical devices and the virtual devices. Now, on top of that, we have our management solution. In Microsoft World, we have Virtual Machine Manager. VMworld is the vCenter server. But between both the hypervisor and the vCenter server, we have functionally equivalent offerings. And these are what we're really going to be focused on over the next 2 days. Now, when we start to think about self-service, one of our private cloud concepts, the key goal here is to enable end users to request resources and free up time from our infrastructure specialists. Now, let's say you have an end user that just needs a new VM. Instead of picking up the phone or sending you an email and asking for it, let's give them a website, give them a button that says, give me a new VM. They push it, they get a new VM. And so what we're trying to provide with self-service is freeing up time for our IT pros, better enabling our end users. And we do that using App Controller, which is equivalent to the vCloud Director. As we look at monitoring, we use Operations Manager. VMware uses vCops, or vCenter Operations Manager Suite. They essentially do end-to-end monitoring throughout the stack: hardware, software, virtual machines, and applications. For protection, we really think about protecting our hosts, our clusters, our virtual machines, and the applications running within those VMs. Microsoft offers Data Protection Manager. VMware offers vSphere Data Protection. For service management, we use Service Manager, and we often see it really used in kind of two distinct ways. First is the traditional IT help desk, getting incidents, solving problems, tracking changes, things like that. The second way that we're often seeing this used is to provide the back end of our self-service portal, allowing again our end users to make any type of customized requests and having us be able to automatically provision that. So we use Service Manager, VMware uses the vCloud Automation Center. And then for automation, we have a technology that was new in System Center 2012 called Orchestrator, similar to vCenter Orchestrator, that allows you to do what we call runbooks, which are predefined automated activities. And this can connect literally any system that has a programmatic interface, meaning functions, APIs, command alerts, scripts. We could go tie those all together to provide any automation end to end. But kind of the key point that we want to just take away here as we compare Microsoft to VMware is we have an equivalent set of features, an equivalent set of products, an equivalent suite of technologies to enable you to go build your own private cloud and to go scale up towards a public cloud. Now, Corey is not a marketing guy with Microsoft. I kind of sit on the fence, half marketing, half technical, but I promise you this will be the only slide you see with a $sign for the next 2 days. What we're just showing you here is a brief overview of the comparisons, looking at Microsoft's suite of products, comparing that to VMware's suite of products. And you can see that generally, Microsoft Suite, it's a little cheaper. But again, we promise you that's all you're going to get about VMware licensing. Key point here is we have an equivalent set of technologies now. So we really want to encourage you, as you're thinking about new deployments, consider using Hyper-V Microsoft Stack, as it's going to give you a lot more advantages that we're going to cover over the next 2 days.
All right, so next small section we're going to do is kind of a quick rundown of System Center. Now, you've mentioned in that quick comparison slide a number of the different products that are involved in the System Center suite. So we'll take a second now and just kind of define each of those.
Yep.
So people know what they are. For example, Service Manager, if you're a virtualization guy, you kind of go Service Manager. I don't know, what do I really use that for? I don't get it. And that's what we'll try and clear up here in this brief section.
Sounds good. So first, let's start from the top here, managing your virtual environment. So Virtual Machine Manager, this is what we're going to be focused on our second day. This is our large-scale virtualization management solution, but it doesn't just manage VMs. It also manages what we call the fabric. Now, the fabric consists of our networking components, our servers and our clusters, our storage components, and then the supporting infrastructure. So this would include our update servers, our Pixie Boot servers, and even third-party hypervisors, such as your vCenter server and Zen server.
Can I inject a minor annoyance?
Absolutely.
I don't like the name VMM.
It seems misleading, Virtual Machine Manager, because it really does more than that.
Virtual machines is a fraction of what it does. It should be, Data Center Fabric Manager. It would probably be a better name for it, quite frankly, than Virtual Machine Manager, because it does switches, it does storage, it does fiber channel, it does, what else in there? It does deployment, it does, bare metal
provisioning.
Yeah. So it's deployment center and switch management center and SAN management center and all those sorts of things. So that just, my
Don't feel scoped down by just Virtual Machine Manager.
Exactly.
We have a whole lot more in there. Now, some of the other stuff, some of the other components, actually, if we could go back one slide, Corey.
Sure, yeah.
So to wrap up, some of the other components, how they relate to virtualization here. So App Controller is, again, the self-service portal. It allows us to basically manage our VMs from an end user's perspective. So if you have an end user, they basically get to see the virtual machines and services that they have access to, but none of the underlying infrastructure. This is provided through a website. So you don't need to go and install a management console. Simply use the website. You're good to go there. Now, we also look at Data Protection Manager. That's going to go back up our virtual machines, those other components. Automation provides automation for our virtual machines and provisioning. Service Manager allows you to make requests for your virtual machines. Operations Manager monitors your virtual machines. And then again, DPM goes and protects those VMs and those different hosts. So as we take a quick look at the overview of Virtual Machine Manager, some of the key features here are simple bare metal deployment. Again, taking a brand new server, installing the operating system on it, booted from VHD, and then making it a Hyper-V host or even making it part of a cluster. We then have the ability to go and actually create these different Hyper-V hosts, create these different clusters, organize them in logical groups, management groups. We can provide cross-platform management covering both vCenter, VMware components, as well as Citrix Zen. some placement optimization, storage management, network optimization, power optimization, and then a whole lot of other detailed features. But again, we'll spend some more time on that one tomorrow.
One of the coolest things I ever did with VMM, and I only ever did this once because, quite frankly, it was a lot of work to set up. But if I had to do this many times, I probably would. Which is, we ordered a stack of servers from some random 4-letter server provider starting with D. And before we got the servers, we knew what the management IPs or the bare metal management IPs were going to be in every single box. We knew what the credentials were going to be. We knew all that stuff. And so with VMM, what we're able to do is go in advance and say, okay, I've got 10 of these things coming in. Define 10 jobs, which represent, find it on the bare metal port, put an operating system on it, join it to the domain, put Hyper-V on it, join it to a cluster, and then we're done. And so when these servers came in, they were dropped in the rack, some cables were plugged in, and some guy went, go. And within, I think it was 2 hours, we had 10 servers in the domain with Hyper-V ready to take VMs.
Very nice.
It was absolutely fantastic. It took a little bit of, like anything, it took a little bit of time to, drivers and get that all built into the images, because you've got to create a WinPE image. You've got to have a VHD that's got everything in it. So that took a little bit of time. But once it worked, it was utterly fantastic.
Now you're teasing everyone. I'm actually going to demo that tomorrow. So stay tuned. You're actually going to get to see one of these bare metal deployments live tomorrow.
I'm keen for that. All right. So if when you think about VMM, so we've got Hyper-V, a bunch of Hyper-V servers. You layer VMM on top, and VMM gives you that global management. But now I want to add in Azure Public Cloud. I want to add in another VMM implementation, maybe from a partner company. That's where App Controller starts to come in. That's
right. So previously we just said App Controller was a self-service portal for VMM. Now it does have a dependency on VMM, but there's actually a lot more you can do with App Controller, as Corey was mentioning here. Let's say you need to scale up to the public cloud. Well, App Controller actually allows you to connect to your Azure subscriptions and deploy VMs that you could deploy on-site up in Azure. So really allowing you to extend your data center to that public cloud. But let's say you don't have Azure. Maybe that you don't have it in your country. Maybe there's legal reasons why you can't transmit the data and store it in a public cloud. Well, we also support what's called service provider foundations. And this essentially allows you to go and use a third-party host's data center, yet still manage it using your own system center components. So when you run out of capacity on site, like I might run out in my data center, I could go run my VMs over in Cora's data center.
I'm not taking your VMs.
You're not taking them?
I've seen your VMs.
You've taken a few of them already in the past.
Exactly. That's my point.
Exactly, yes. Lots of emails this past weekend about problems with VMs.
The Service Provider Foundation is a pretty neat concept in general, because what it allows if you're a hoster, and there's lots of big hosters in the world that do infrastructure hosting, and you want to enable people to, hook into your stuff via APIs, via automation, you would have had to build something, and they would have to adopt your framework. What Service Provider Foundation allows you to do is take this generic layer that we know interfaces with all the Microsoft components that you as a hoster can put in front of all your infrastructure, and gives you all that functionality automatically.
Yep.
And just translates it all through. So it's a really neat component.
And guess what? We're actually going to demo that one as well tomorrow. We're going to go do a deployment out to our service provider. Excellent. Not you, sorry.
No, not me.
You weren't set up for that one.
Nope. So moving on to our next small section, which is looking at evaluating the current environment for virtualization. So what are some of the things we want to think about as we look at moving towards a virtualized solution and some of the different elements of that? So number one, things you got to consider. I mean, some of this is very obvious stuff that relates to any general project. Scope, hardware requirements, compatibility, applications and services, what things are supported and what things are not supported, licensing, availability, and the undocumented political element of it all. There's lots of cases where I've been involved in companies doing virtualization migrations where there was some server that we're sitting here going, why is that not in a VM? Because they won't let us. Why? Because they said we're not allowed. And you never get past that. Well, at some point you go, okay, you're making a dumb decision, but you can lead a horse to water. But and we kind of see that a lot. Two other things you want to kind of think about of this list that are probably the most important. One of them is supportability. You need to look at, are the applications that you're running going to be supported in a virtual machine? And there are, applications out there, especially some older applications, where the software vendor just says, you know what, we're not supporting it in a VM because we don't have the budget to do all that testing. Even though it by definition doesn't matter. It does factor in, and I've seen people get burned where, they have an application, they install it, and then there's some issue 2-3 months down the road, and the company that provided it goes, well, we'll help you once you reproduce it, not in a VM. So just, you've got to bear that in mind. It really is a kind of a stupid little thing to have to deal with, but you do have to deal with it. And then licensing. You get a lot of benefit from operating system licensing when you choose to run things in VMs. And we'll talk more about this later on, but for example, on Windows Server Data Center Edition, you get unlimited guest operating system licenses for data center instances. So rather than having to buy 30, 40, 50 licenses for Windows, you only have to license the host. Then all the VMs are free. And they've now introduced automatic activation, so you don't have to worry about activation anymore.
Very cool feature.
It really makes it easy to do. Now, to make this all simple and easier, we have something called the Microsoft Assessment and Planning Toolkit. We have also something called the Infrastructure Planning and Design Guides. Many of you, if you're old like me, might remember something called the Windows Server Reference Architecture, which was a set of documentation that Microsoft did about 7 or 8 years ago. That was one of the best pieces of documentation I've ever seen in my life. It was basically, if you're an enterprise, you want to deploy every product Microsoft has in the best possible configuration, here's a 60 million page document on how to do it, right from hardware to permissions on user accounts on database files, everything. And it was phenomenal because you could use that as a guide, and a lot of companies did use that as the guide for doing their implementations. Well, that's been improved, chunked up, made smaller, made more consumable, and the result is the Infrastructure Planning and Design Guides, which is a set of documentation that you go search for this using your favorite search engine, and then just download them, and you pull out whatever document you want, whether it's it's virtualization, whether it's application deployment, whether it's configuration manager, whether it's security, whether it's firewall stuff. And it's all the considerations and best practices and recommended configurations are all right there. You take them, modify them, tweak them, just put them in place. Now, the one tool that we mentioned was MAP, the Microsoft Assessment and Planning Toolkit. This is something that gets updated, it feels like every 2 weeks as new hardware becomes available, as new solutions become available, as new recommendations become available. But essentially what this will do, you install it on a machine, it will use anything from subnet ranges, domain memberships. It'll even interrogate Configuration Manager if you have it. Find every system on your network within the scope you tell it to search, and then evaluate it for things like virtualization. And this applies for not just virtualization, but deployments for, you can do it for security, for firewall stuff, for application compatibility. The focus here would obviously be virtualization, but you can say, hey, here's my network. Find me all the servers out there that are good candidates for virtualization. And it'll go find them based on operating system type, whether or not it's physical machine the hardware it's running on. And then even if you tell it to, watch it over a period of time and gather performance metrics. The result is it will give you direct purchase recommendations on things like, hey, go buy this fast track kit configuration 1. This many disks, this much RAM, this many hosts, and this will cover everything I found. And as I said, it continuously updates itself as new product offerings become available. But it's a real good way, if you want to, kind of impress your boss, you go, hey, give me a week, and I'll come back and give you tell you exactly what hardware to purchase. And you just tell MAP to go do it for you. Get
a detailed report at the end. Yep. And it's all free, so it's a free
completely
download
free.
available online
and
as well.
At the end of the day, you get it comes out and says, hey, go buy this, this particular fast track, click, and here's the link to the purchase option. Click spend $200,000, and away you go. So with that, move on to our next section here, which is extending virtualization to the cloud. So Simon, let's talk a little bit about Windows Azure for a second and where this fits into the overall virtualization strategy.
Absolutely. So Windows Azure, you guys may have heard us mention Azure before. I don't know. You guys may have heard Microsoft mention cloud before. Those terms get used a lot. So what exactly is Azure? Well, simply, it is our Microsoft public cloud offering. It is a set of infrastructure hosted in Microsoft's own data centers located around the world that you can use, that the public can use, that anyone can use to take advantage of infrastructure and different platform and messaging services. So essentially, it's offering IT as a service. Now, there's really 3 different types of service models provided by a cloud: platform as a service, infrastructure as a service, and software as a service. Now, Platform as a Service, this is essentially offering your developers a set of connected infrastructure that they could go build their applications on. .NET applications, Java applications. It's basically providing that foundation with all of the connected components so that these enterprise applications could communicate with each other. Now, Infrastructure as a Service was a new offering Azure came out with about 6 months ago, summer 2013, which basically allows Microsoft's infrastructure to be made available for you to do with it what you want. So if you say, I need a new Windows server, we could go give you a new Windows server in a matter of minutes. So pretty simple to go get spun up, to go get up and running with your Azure infrastructure. And we're going to show a demo of that a little later, going and actually connecting to your Azure infrastructure, deploying a VM. Then finally, we have what we call Software as a Service. And this would be something equivalent to, say, Office 365, where we're actually just providing the software online that you can connect to. So you don't need to go and install Microsoft Office across every client machine. People could just access this type of application.
It's not just Office,
in the
right?
cloud.
It's Link,
lots of applications,
Link, CRM.
Yeah. Exchange Online is one of the most popular ones as well.
Absolutely.
SQL Azure, so a lot of applications.
SharePoint is a huge one. We use Office 3. We retired our Exchange servers about a year or so ago at our company. Just, we don't want to have to manage them anymore. It's just we're not Exchange experts. We just need email, but we want Exchange caliber email. And so for a couple $100 a month for the entire company, we don't got to worry about it or think about it ever, which is absolutely fantastic.
Absolutely. And actually, if we can, let's switch over to my laptop here. I'll actually show you a quick demo of us doing a infrastructure as a service deployment. So what you see here is the Windows Azure portal. I just go to manage.windowsazure.com, sign in with an account, and you can see right now, this is the overview page. I have a couple of services and applications running. Now, as we look along the left side of our screen here, we can see we have options to deploy websites, virtual machines, different types of mobile and cloud services, even Visual Studio if I have developers that want their own Visual Studio instance. But let's just take a quick look at how simple it is to go create a new virtual machine. We go down and say New VM. Now, one of the nice things about Azure, it comes with what we call a gallery, a set of pre-configured applications and services. So as I kind of browse the gallery, this means that if I pick one of these VMs for, let's say, SQL Server 2014, SQL Server comes pre-configured and pre-installed. So I don't need to go through that additional step of downloading SQL, installing it, getting it configured. We get it up and running. Now, we also support other Microsoft applications and also other third-party applications. Recently, Microsoft announced a new partnership with Oracle, and we're actually the only hypervisor that supports Oracle applications, which Oracle doesn't own. Oracle does actually have their own hypervisor, but Hyper-V is the only other one that will support their applications. We have other development studios and frameworks, so JDK, and then, of course, our different Linux distributions. So with Hyper-V, we do have a pretty broad offering of guest operating systems that we support. Of course, all the Windows Server and Windows Client, but then many of the most common Linux distributions.
So Windows Azure runs Hyper-V, obviously.
Windows Azure runs Hyper-V, but within those Hyper-V virtual machines, that's where we can go and configure all these additional components.
But the underlying fabric for Windows Azure is the same Hyper-V that
that's correct.
You get in your own data center.
And so that's what gives us some portability between our on-premise virtual machines and moving them up to Azure, because we can run those same VMs that I build, those same VHD files, upload them to my storage in Azure, and once they're in my storage, actually go create a VM using that VHD. So it gives us kind of that portability between the different clouds.
Not to get kind of too far ahead of ourselves, but there's a few more steps to just throwing a VHD in Azure. You've got to make sure that, for example, RDP is turned on, because that's how you get connection to the desktop of the VM. So we'll go through this. I guess tomorrow is when we'll dig into some of that.
Yep.
But it's you can take a VHD off your local Hyper-V server, push that to Azure and use it. A few little things you got to do to make sure it's going to be compatible and work, but those are all very well documented through the tools that you get.
Absolutely. So really, trying to give this flexibility with deployment. Now, let's go ahead and just quickly pick one of our virtual machines here. I want to make sure I'm using the latest and greatest Windows Server 2012 R2. I get to give it a name. So we'll call this Jumpstart. And we'll just give it a unique number as well. We get to pick what type of cores we want to use, so very large amount of memory, very small amount of memory. Provide a username for myself and a password. Click Next. We then get to say what type of cloud service are we going to go run this on. So basically, what logical grouping do we want to go place this virtual machine within? And so this means if you're a developer, you have a bunch of interconnected virtual machines, you're going to try to want to run them on the same fabric so they have faster network communication and can share some other components. We then would get to pick which region we want to go deploy this in. Now, since my cloud is already set up in the US West, and I'm going to be part of that same cloud, we're going to stay connected to that. We get to go and use a new storage account, pick our own, and then we have an option of creating an availability set. Now, an availability set is something we're going to talk a little more about with Virtual Machine Manager, but essentially what it does is it forces two virtual machines to run on different hosts. It does what we call anti-affinity. Now, the reason why we want to do that is simply to provide higher availability. Let's say you had two applications that are running inside VMs. Both of those VMs are on the same host. Well, if you lost that host, that's a single point of failure. You're going to lose both VMs.
Well, where that becomes particularly important is guest clustering.
Absolutely. So the different cluster nodes running as VMs.
Yeah, and we've got a modular and high availability towards the end, but to kind of briefly describe that scenario, let's say that you want to do a highly available Exchange implementation. Well, you wouldn't want to put both nodes of your Exchange cluster on the same Hyper-V node, because should that node go down, well, the whole cluster goes with it. So you'd always want to spread that out and say, this node of the Exchange cluster goes on this host, and then the other node can go on any other host, so that you don't have the single point of failure. And that's where the anti-infinity comes in. So these concepts of guest clustering, host clustering, and all that will come later today in more detail.
Absolutely. So you're going to see a lot of consistency both within Azure as well as on-premise with Core Hyper-V, and then again up to our data center management with System Center. Finally, we get to confirm the information. I could go configure my connection protocols. Click OK. This is then going to go create, and we will then have our virtual machine up and running. Well, back to you, Corey.
All right, so just kind of taking a look here on the slide deck real quick as a bit of a summary of what Simon had just gone through for virtual machines in Windows Azure. Built from scratch, meaning they're deployed when you define them. They're not in a predefined saved state or in a predefined deployed state, like, for example, our lab VMs would be. They're actually deployed using unattended XML files from generalized VHDs when you deploy them, using any of the available templates. And then any applications that might be part are always going to be pre-installed. And you can customize this all you want. So you can take what's there by default, or you can go very, very detailed on the customizations, applying your own unattended XMLs, your own VHDs with your own applications, whatever level that you want to go to. Or you can upload VHDs and actually import them. So that pretty much sums up Module 1, kind of getting us all started on the big picture of virtualization on a Windows infrastructure, everything from Hyper-V, which is the local on-premise hypervisor, to Virtual Machine Manager and App Controller to manage large-scale deployments, right up to Windows Azure as the public cloud side of things.
Now, there is one other component that we should mention here, which is the Windows Azure Pack. Now, Windows Azure Pack is a new capability released with our latest R2 wave. So it requires Windows Server 2012 R2, System Center 2012 R2, and essentially it allows you to run Azure-like services in your own data center. No internet connection required. So if you like that interface that I just showed you, where you can create virtual machines from Gallery, create your own platform as a service offerings, yet maybe you don't have access to a public internet because you're a government organization, you have certain legal or compliance requirements, being able to go build your own public cloud, being able to build your own cloud on-premise is a great capability. And you're going to see a lot of ongoing investment towards the Windows Azure Pack coming from Microsoft, really providing a much better self-service experience, end-user portal, allowing you to run these great data center services in your own data center.
Yeah, the other sort of reason you might want to consider the Azure Pack is because you're running it on your own infrastructure, you get more direct control than you do with Windows Azure, for example. With Windows Azure, it is what it is, right? They control everything about it.
And there are some limitations, right?
Sure,
you have
absolutely.
to work within those, yep.
You get to kind of expand those a little bit. You get to define what the hardware is. You get to define everything around it by putting it in your own data center. So you get that same Azure level of automation, flexibility, the great user experience, but you can decide whether it's going to be faster or slower, whether you want more disk, more memory, more CPU, whether you want to enable configurations that Azure might not choose to enable because you have more control over everything. They've got to think about everybody. You don't only have to think about yourself.
Great point, great point.
So-
Well, we will say that Windows Azure Pack, we're not going to spend a whole lot more time on that. If you want to learn more about that, you can go to windowsazurepack.com or microsoft.com/Azure and check out the different Azure services. With that, we are just going to wrap up our first module here.
Yep.
You know, to quickly summarize, we've kind of hopefully given you the foundation, covered some initial best practices, and very shortly we're going to be moving on to our next module where we look at installing and configuring the Hyper-V role. So stay tuned. We'll be back in approximately 10 minutes.